except now it's just started, so you want to do that again.
Good morning.
Okay, that's from Jared mostly. All right, so these are perfect square trinomials, and when you have a perfect square trinomial, one of the things you'll notice is the first term is a perfect square, and the last term is a perfect square. And so when you work this out, you can actually do it with a box and a diamond problem, or a shortcut is to say the answer is going to be x plus 5 quantity squared, because the square root of x squared is x, the square root of 25 is 5. Now to double check that, because we do have a middle term, if you take, this is like a 1x, if you take 5 times 1, you get 5, and if you double that, you get 10, and that has to be true if it's a perfect square trinomial. So for example, on the next one, x squared is a perfect square, the square root of x squared is x, the square root of 9 is 3, so we think it's going to be x plus 3 quantity squared. If we multiply 1 times 3, we get 3. If you double that, you get 6. And so that works. On the next problem, the square root of x squared is x. The square root of 16 is 4. But because this is a minus sign right here, we're going to have minus 4 instead of plus 4. And we can double check again. 1 times negative 4 is negative 4. And if you double that, you get negative 8. On this last one, and this is where it can save you a lot of time, the square root of 4x squared is 2x. Since they're both plus, this is going to be plus. The square root of 9 is 3. So we think this is the answer. And if you check this, 2 times 3 is 6. So we have 2 times 3 is 6. And if you double this, you get 12. So that means it works. So in general, for perfect square trinomials, this has to be the pattern. If the first term is a perfect square and the last term is a perfect square, and the center term has to be double the product of whatever the square roots of those are, then you would rewrite it like this. If this is a minus sign here, then this will be a minus sign here. And this is a formula. You'll find this formula on your factoring flowchart. And you can do all of these problems by using a box and a diamond, but it can save you time if you know how to do it that way. All right, today's learning target, I can factor polynomials with more than 3 terms by factoring. So in this case, for this first example, we're factoring 4x cubed minus 2x squared minus 14x plus 7. And when you have 4 terms, you're going to find that these are pretty simple to do, because you're going to do a box. You're going to put 1 term in each box. Make sure you use the sign. If it's negative, then put a minus. So we have 1 term in each box, and then all you do is pull out the common factors. So in this first row, we have a 4 and a negative, or a 4 and a 2, so I'm going to pull out a 2 here. And I can also pull out a factor of x squared, which leaves me a 2x here, because if I multiply 2 times 2, I'll get the 4. X squared times x gives me the x cubed, which means this has to be a minus 1, since a negative 1 times a 2x squared would be negative 2x squared. This would have to be a negative 7. 2x times negative 7 is negative 14x. And double check the last box. Negative 1 times negative 7 is a positive 7. And you're done. So you have 2x squared minus 7 times 2x minus 1. And since they're both subtraction, I suppose I could double check, especially this, to make sure I didn't have the difference of 2 squares, because it's possible you could have that, but I don't. So this would actually be your answer in factored form. So when you have 4 terms, you're going to make a box, and you're going to put 1 term in each box. So these you should find are not too difficult. So let's try another one. So go ahead and copy the problem down and create the box. So I'm going to have 7n cubed minus 4n squared plus 14n minus 18. And then I look for common factors. So no number can come out of the first row, but I can factor out an n squared, which makes this a 7n. and this a minus 4, I think we're going to have a problem on this one. And because this would have to be, yeah, this one's not going to work. So hold on, because sometimes what will happen is the way that you arrange it in the box, it might still be factorable, but the way that I might have to rearrange some of the terms in the box. So we're going to try that. Okay, the way that I had that problem written was not factorable. I had the wrong number written down right here. I intended that to be a minus 8 instead of a minus 18. So now we have it fixed. So we have 7n cubed minus 4n squared plus 14n minus 8. Now I can factor out just an n squared here, which makes this 7n. And it's going to make this a minus 4, because negative 4 times n squared is negative 4n squared. 7n times, this is going to have to be a 2 in order to make that a 14n, and it would have to be positive. And I check the last box, negative 4 times 2 is negative 8, so that works. So our factors are n squared plus 2 and 7n minus 4. And now that one's done. All right, next problem. Now, sometimes you can have more than one variable, like you'll see here. I have a u and a v. No big deal. You're still going to put, notice I have 4 terms. I'm going to put 1 term in each box. Now, I don't do any of these today with more than 4 terms, but it's possible you could have 6 terms, and you would just do a bigger box and put 1 term in each box. So, which can sometimes happen. We won't see that maybe at all. So I'm going to have a 30 uv, 35u, negative 36v, and a negative 42. Then I look for common factors. So out of the first row, I can bring out a 5u, which is going to make this a 6v. It's going to make this a plus 7. And this would have to be a minus 6. So 6v times negative 6 is negative 36v. Don't forget to check the last box. 7 times negative 6 is negative 42. So then we know we did that one correctly. We get 5u minus 6 times 6v plus 7. Okay? You go ahead and tell him, Jared.
Go ahead and try this one, guys.
Okay, say it real loud because I don't know if the microphone.
Go ahead and try this one.
Okay, so I'll pause it in case they want to try that. Okay, so this is what you should have gotten for an answer. So we have 7x minus 6 times the quantity 4y minus 1. So we're good? All right, so one more example. So let's try this one. Now, one of the things that will sometimes happen, and this might be one of the cases where it does, when you put the numbers into the box, you might not have it work the first time. So you might have to rearrange the numbers. So let's see if this is one that's like that or not. So you might just start by trying a number in each box. So I'm going to factor out, 3 goes into both of those, so I can factor out a 3, but there's no variable to factor out. And that would make this an 8mn. And see how I'm going to have trouble here because I don't have anything there. I don't have an n in here. So that first arrangement doesn't work. So this is a problem where you have to kind of think about how you're going to group it. So it's not going to, so if it doesn't work the first time you arrange it, then just kind of stop and think how you could arrange it to make it work. So I need to have either an m or an n factor out of this. So I'm going to try putting the negative 18m in this spot because now I can factor a number out of 24 and negative 18, but I can also factor an m out. And then since I have an n in the first box, then I want my term with an n to be in this box so that the n can factor out that column. So you want to try and put a common variable in the same row or in the same column, and then my constant number is going to be over here. So hopefully this will work for us. So if we factor out a 6m, then that makes this a 4n, which makes this one down here a -7, and this would have to be a -3. -3 times 6n is -18m, and -3 times -7 is 21. So that works. All the boxes work. You can multiply to double check. So we get 6m minus 7 times 4n minus 3. So again, my strategy on that was to make sure, since I had two variables, make sure that one of the variables lined up in the same column and the other variable, the common variable, lined up in the same row. And if you do that, then you can find a way to pull out the common factors. But it is possible, like the one that I messed up on when I wrote the wrong number down, it is possible that you try something like this and it's not factorable, and if a problem is not factorable, then you could say it's prime. But as you can see on this example, if you just put a number in each box and then you said, well, it's not factorable, you'd be wrong in this case. So first, before you just say it's not factorable, try and rearrange the terms in the boxes and see if you can come up with a common factor.